Hello, class. This will be the recorded lecture continuation in section 5.1. And we're going to continue polar coordinates and talk about polar equations a little bit. And next section, we're going to do graphing. And so let's get started by doing a conversion of a Cartesian coordinate into a polar coordinate. And so Cartesian is the same as rectangular, and I believe in the book they use the term rectangular. But say like we have this equation or this graph here, where x equals -1 and y equals -1. So where are we? Well, it would be here and here, and so that would be the point. So what quadrant we're in? We're in quadrant 3, right? And so this would be the R value, and this would be theta. So typically when you do the conversion, the R value is typically going to be greater than 0, and the theta value is going to be between the number 0 and 2 pi, but we don't, I believe it, since 0 and 2 pi are the same number, right? We don't include the second endpoint with regard to that. So what do we do? Well, we know what x and y is, so we could start with r squared. So r squared would be minus 1 squared plus -1 squared. And you can see that would give you 2. And so r would be plus or minus the square root of 2. But since we're making it the conversion that r is always positive, so we'll use square root of 2 for r. So this length right here is square root of 2. So what is theta? Well, here we'd have to do tan inverse of -1 over -1, which gives us +1. So if you did tan inverse, you got out your calculator or looked at there, you would get 45 degrees or what? Pi over 4. But you're getting the angle in the first quadrant. So how do we convert it to the third? We add 180 degrees to it, or add pi. So to move it from here all the way to where we need it in the third quadrant, it would be pi over 4 plus pi. And so that would give us 5 pi over 4. So this would be in the polar coordinate system, square root of 2, 5 pi over 4. Okay, so I hit pause and I erased the board, and we're going to start converting some equations now. And let's first talk about some circles, because you'll see that the big benefit of polar coordinates is the idea if the equation has a lot of curves in it and there are circles, the polar coordinate system is a much better way of representing, say, circles than the rectangular coordinate system. Same with lines, right? If we have nice straight lines, the rectangular will be better than the polar. And so let's start with this equation. And this is the simplest equation of a circle. X squared plus y squared equals 1. And so if you remember, let me write up here, x minus the center of x plus y minus, squared. Almost forgot my squared there. And then y minus yc squared equals, I hate to use this r, but let me use d. No, I got to use r. It's not the same r. Let me, instead of use r, use r little radius. R little r squared. That's our equation of a circle. And so here the center is 0 and our radius is 1. And so the equation or the graph would look like that. And so this point here would be 1. This point here would be another 1. And remember, the radius comes from the center. So how do we convert this? Well, this conversion is pretty easy, right? Because if you look on what we want to do to convert, I'll put that in green, r squared equals x squared plus y squared. So we just get rid of that. R squared equals 1. And so you could see that this r squared equals 1 gives you a nice equation of a circle. So one of the things that you could do to simplify this, right, is to say square root both sides. And so that would be r equals 1 is also the exact same equation. And so this would be an equation of a circle with a radius of 1. And you can see that theta is not involved there because theta could be any number all the way around 360 degrees. Okay, let me give you another one. So let me pause and erase this. Okay, so let's take a look at another equation here. And let's do one where we have a nice straight line, x equals the number 5, right? And so that would be this vertical line at x equals 5, right? So you could see nice representation of a vertical line. And so how do we convert that? Well, first of all, you convert it by plugging in r cosine of theta, wherever you see that x, right? And that would equal 5. So just like in well, let me rephrase that. Typically what you try to do is set a polar coordinates where r equals something if possible. Just like we did in the last one, we took the square root of both sides and made it r equals 1. In this case, what we're going to do is divide each side by cosine of theta. And so when you do that, you have r equals 5 divided by cosine of theta. And we know that 1 over cosine is secant. By cosecant is secant. And so I believe that when you do some of the homework in WebAssign, they're going to want you to convert it that way. Cool. Okay, so let's do one maybe a little bit more complicated now. So we did a circle and we did a line. And so let's do one that looks like this. Let's see. So this one would be r equals 2 sine of theta. And let's convert this into Cartesian. Well, how do I get rid of the sine of theta? That's really the first thing you want to think about. And the idea of that is you need an r in front of it, right? And we could replace it with a y. So the strategy here is let's take each side and multiply it by r. So we end up with r squared here. And then we have 2r sine of theta, all right? And so we can get rid of this by, this would be 2y. And we can get rid of this by x squared plus y squared. So this would be converted this way. And again, this is the transformation. But in our math life, we usually try to put it in what we would want as a standard form. And in this case, our standard form is going to be the circle. And this circle is standard form looks like I've written up here. So let me show you how to do that algebra again. Hopefully this is a review. So first thing you want to do is we have this one set up where we have x minus 0 squared, right? And so the center for the x value is going to be 0. But the y center, we don't know. And so what we're going to do is the strategy is to bring everything to this side, all the variables to one side and set it equal to some value. In this case, it's going to be 0. And so to finish this, to get the equation of the circle, we want to do something back in the algebra days we called completing the square. And when you complete the square, what you want to do is, if you remember, it was let's say y squared plus by squared plus c equals 0, right? And so the b value, whoops, sorry. So that b value is in front of the linear term. So what you wanted to do when you completed the square was you took the b value and you divided it by 2. And then you squared it. And by doing that, you would automatically complete the square so you could set it up in the standard form for the circle equation. So what is it? B in this case is our -2. So that would be -2 divided by 2 squared, which is 1. And if you square it, or -1, excuse me, and when you square that, you get +1. So what you do is you have to add a +1 on this side and a +1 on this side. And so this would be, again, -1 squared. And so the way that you usually don't write the 0, right? So this would be x squared. And then so that when you complete the square, the y value looks like this, y -1 squared, right? And then that equals 1. So you could see the radius is 1, and center of our circle would be x equals 0, y equals 1. And so that's when you do this transformation, WebAssign is going to ask you to put it into the standard circle form, which looks like this. So that ends the recorded lecture for section 5.1. The next one, we're going to talk about how to graph some of these equations and the polar coordinate system.